Hey everyone, it's Dr. Joyce here. Let's talk about the innervation to the lungs, and of course, let's orientate. When we talk about innervation to any visceral organ, it's important to first understand the basic arrangements of the nervous system. So let's zoom in onto a blank space and let's talk about the general arrangement of the nervous system. So we know we can classify the nervous system anatomically and functionally, so we'll do both. So we have the central nervous system, and we have the peripheral nervous system. So those are the anatomical classifications of the nervous system. Central nervous system is everything in the center, so the brain and the spinal cord, and then the peripheral nervous system is everything else. Now within the peripheral nervous system, we have the functional divisions, which are the somatic nervous system, the autonomic nervous system, or the ANS, don't say that too fast, or the enteric nervous system. Now the enteric nervous system, it's not really relevant with to the respiratory system, but it is relevant when we talk about the GIT. So let's think about it. The nervous system needs to firstly, in order to create an appropriate motor response, it needs a change in the internal environment or the external environment or both. And that change and that stimulus needs to be sensed. So these signals are carried via the afferent fibers. So in the somatic nervous system, this will be the somatic afferents or the sensory somatic afferents. And that signal will go up to the brain and the spinal cord. It will get integrated and an appropriate motor response will be produced as a result. And this will be what we call the somatic efferents or the somatic motor, usually to skeletal muscle and things like that. So things under conscious control. Now, when it comes to the autonomic nervous system, it's the same concept. It wouldn't really be appropriate for the body to be producing random motor responses without firstly a reason for it. And that reason, again, comes from the visceral afferents, so the sensory fibers. And then again, that signal goes and gets integrated either in the spinal cord or the brain, and the brain will produce a motor response, and that can either be a sympathetic motor response or a parasympathetic motor response. So let's go to the lungs now and let's see what we have here. So we have the sympathetic motor and then we have the parasympathetic motor, kind of like schematic stencils that we're going to fill out. So we know that the parasympathetic innervation to the lungs comes from vagus nerve. We know that vagus nerve is cranial nerve 10, and we know that cranial nerve 10 comes from the medulla. So we'll just put in here just a general cell body over here, with the nerve being represented by this line. So this will be vagus nerve, and this will be synapsing into the pulmonary plexus. Let's talk about the sympathetic innervation to the lungs, so sympathetic motor innervation. We know that this comes from T1 to T4. So let's see what happens, and let's focus on the left-hand side of the diagram. So here we have a stencil of the spinal cord from the levels of T1 to T5. This here is the sympathetic chain plus the associated ganglia. We have the dorsal grey horn. We have the dorsal root ganglion. This is where we will have the cell bodies of the sensory neurons that we'll talk about in a second. And of course, here we have the ventral grey horn. And something unique in the thoracolumbar spinal cord is that we have the lateral grey horns, where we have the preganglionic neurons of the sympathetic motor nervous system originating. So from T1 to T4, we have the cell bodies. So we'll just draw like a little dot here to represent the cell bodies of the preganglionic neurons. Because they're motor, they're going to travel through the ventral root and the ventral rootlets, and they will synapse in the sympathetic chain ganglia of that level. So that's from T1 to T4. We don't actually need this one in T5. So then from the sympathetic chain ganglia, if these are the preganglionic neurons, the ganglion in question is the sympathetic chain ganglion at the different levels. So from here, from the sympathetic chain ganglia, we get the cell bodies of the postganglionic neurons, and these make their way to the pulmonary plexus. And because they're coming out medial to the sympathetic chain to innervate the visceral organs within the thorax, we call these the cardiopulmonary splanchnic nerves, and they will also synapse in the pulmonary plexus. So we've covered the sympathetic motor innervation and we've covered the parasympathetic motor innervation. So what's missing here is the visceral afferents. So a general rule of thumb in the thorax and the abdomen is that the visceral afferents will enter the spinal cord at the same levels as the sympathetic motor innervation. This just simply means that the sensory neurons will go into the spinal cord at the levels of T1, T2, T3, and T4. So this corresponds to the levels of the sympathetic innervation. So we can draw them in. So again, we have the visceral afferents represented here. We have the pulmonary plexus over here, and we're going to enter the spinal cord at the levels of T1 to T4. So the autonomic nerves are unique in the sense that they will go through the sympathetic chain, and they'll go through the white ramus communicantes, and then we'll find the cell body of this visceral afferent neuron within the dorsal root ganglion, which is over here. So cell body of visceral afferent neuron. Same thing will happen at the level of T2. T3. And remember, the white ramus is always the one that's more proximal to the spinal cord, and it contains the myelinated fibers, like so. So at the same time, we have the visceral afferents entering the spinal cord at the levels of T1 to T4, but remember that we have other types of sensory information, such as somatic sensory or somatic afferents. So this means that other sensations can enter the spinal cord at the levels of T1 to T4. And for this, we kind of need just, a brief schematic of the thorax and its dermatomes. So here we have the neck. We have the nipples over here, which create a landmark dermatome at the level of T4. So if this here is T4, up here would be T3, T2, and then T1, and then T1 is kind of like on the medial aspect of the arm as well. Okay, so these are the dermatomes. So this is the somatic nervous system coming in now. So again, here we can have the somatic afferent signals also entering the spinal cord at the levels of T1. So it goes through the spinal nerve this time, but we still find the cell body of that somatic afferent neuron in the dorsal root ganglion. Same thing for T2. This is probably going to get a bit messy. Same thing for T3. And of course, same thing for T4. So then in the dorsal grey horn, we have something that we call the interneuron, and the cell body specifically of the interneuron. And this interneuron will take up all of this sensory information to the brain, and the brain then tries to integrate and tries to work out where the sensory signal is coming from. And it usually can't. So this is the anatomical basis of visceral referred pain. It always thinks that that sensory signal is coming from the dermatomes because the sensory homunculus is so nicely mapped and so accurately mapped compared to the visceral organs, which are not. So this is, again, the anatomical basis of visceral referred pain regarding the respiratory system, but also the cardiac system, so the heart and the visceral layer of the serous pericardium, because they also share the same innervation.